All right, so let's start talking about Java. So you've got your first ODP, right? So let's talk about what's going on in this program. Right, so this is the program you're writing for ODP 300. It's a basic boilerplate for a main program, right? And we don't need to understand what all these details mean. We can type this in and compile it and run it and it'll work fine, and that'll actually get us pretty far. But let me give you a high-level view of what's going on here, and we'll be refining this as we go through the course. Everything in Java is basically what we call an object, okay? And objects are basically variables of different data types. So think in C, when we have a struct statement, we can make a structure called student, and it contains a student name, a student ID, and a GPA, right? So it's got 3 different data fields associated with it. And we can make a variable S1 and say this is a variable of type student. So we'd say struct student S1. And then S1 has a name, a student ID, and a GPA. And we can say S1.name, and that's the student's name, and so on, right? So that's the C version of structures. Same thing is happening in Java, but instead of a structure, we talk about classes. So we're saying that we're defining a class called myMain. Okay, myMain is just what I decided to call the class. It's like what I called my structure. I decided to call it a struct student, or a struct my student, or whatever. So this is a structure called myMain. And inside this structure, I'm declaring a function. And this is basically telling me what kind of function I want to declare. Public static void. Okay, so first of all, main is the name of the function. And main is a sort of magic function name. It means this is going to be basically a main program, just like main when we declare a main inside a C program. This has got to be main, lowercase, everything's case sensitive. Void is the return type. It could return an int, it could return a float, it could return a void. Okay, main programs always return voids. And public, when we create functions, we can say who's allowed to access this function. And this is not other users on the system, okay? This is, for example, do we want other things inside the same file to be able to execute main? Do we want something from outside this file to be able to execute main? And we can make these things private, we can make them public, we can do other things like protected and so on. So we're just going to say public because this is our main program. We want to be able to run it from the command line typically. Static is going to take a while to actually get into an explanation of. For now, it's just something that has to be in there. So public static void main declares our main program. And this business over here, this is what we're doing instead of argc argv. So in C, we say integer argc char star star argv. And what's that doing? It's making argv an array of char star, and char star is a string. So char star star argv says argv is an array of strings. First string, second string, third string, and so on. That's exactly what this is doing. Okay, string is a type of variable. And Java actually has a variable type known as a string. It's not an array of characters, it's a string. Okay, it's a bunch of letters with a certain length. And when we say string bracket bracket, we're saying this variable is an array of strings. If we say int bracket bracket, we're saying we have an array of integers. So this is saying that main is a function that takes a single argument, which is an array of strings. So this is kind of an analog to what we do when we make a main program in C.
So why is string capitalized?
String is capitalized because that's how we call strings. Okay, there's an integer type variable which is an uppercase I, integer. It's another variable type. The more precise explanation is it's a class, and by convention class names are uppercased. But for now, just think of it as this is what it's called. So this is declaring a main program, curly brackets, same as C, begin and end the function, and then everything in between is the code that makes up the body of this particular function called main. And we can think again for now of this as just being a function like printf, system.out.println. And one way to think of this, it's not totally accurate, but instead of saying number sign include in the beginning, right, what we do here is we say system.out.println. This is helping the system understand what we mean by println. Okay, it's referring to a particular function in what's eventually going to be to us another class called system. So when we want to print something, we say system.out.println, and then we can tell it what we want it to print. So it's not all that bizarre. So here's my class myMain, and it's in myMain.java. So this will compile it, and this will execute it, and it prints out what we asked it to print. So let me save you a few gotchas. You can't just say Java C myMain. You got to say myMain.java. Okay, it's going to insist on that. And to execute it, so when we say Java C, it creates this myMain.class. Okay, that's kind of like the compiled version of myMain.java. It's binary, so we can't do anything with it, but the system knows how to interpret this, and we run it by saying Java myMain. If you say Java myMain.class, you'll get an error also. So there's a bit of an asymmetry here.
Wouldn't .class kind of be like a .o?
It would be like a .o, yeah. So to compile, we say Java C file.java. To execute, we just say Java file, and that means we want to execute file.class, but we don't actually put the .class there. So that can be a little strange. Okay, we can write a function called mmmmain, and that's perfectly fine. But if we try to execute it, it's going to give us an error, because when we say Java class name, it's looking for a function named main that takes an array of strings as an argument and is of type public static void. And it even reminds you here, right, it's looking for a public static void main. So it'll keep you fairly honest. And I can declare a main program and say I'm going to take an integer argument instead of an array of strings, and it compiles just fine. But when you try to run it again, it says I don't see what I'm looking for. So already it's trying to keep you honest in terms of if you make a main program in C and you make your argument an array of integers instead of an array of strings, and you try to run your program, you probably get a seg fault. Right? this isn't even going to execute your class for you because it's expecting this very particular type of argument to your main program.
It's more helpful.
Yeah, and this is one of the ideas of Java is to try to sort of put everything on the same footing, right? So trying to prevent these sorts of kind of silly mistakes. That's a double-edged sword, right? To me, that takes away flexibility and some things that you might want to do deliberately, but it kind of forces you to play by the rules. So this print line statement, so you can declare variables, right? There's a regular integer int. And we can say print line x. And it prints out the value of x. And we can also string things together with a plus sign. We can do concatenation. So I'm going to print out the symbols x equals sign, and then I want to tack on the value of x, right, which is a fairly intuitive thing to want to do. And it does exactly what you would hope it does. So no more x equals %d unquote comma blah blah blah, right? And I can do something like this, x equals x, and 2 times, and I'll print the value of x equals, and I'll tack on the value of 2 times x. So that's a little nicer. And if you get rid of these parentheses, you may get in trouble. Nope, that works. But if I wanted to print out the value of 2 plus 2 or x plus x, right, I need to put that in parentheses. Otherwise, it's going to print x and then concatenate x to the end of that. All right, so print line is nice. And if you want to print without the new line at the end, you can say print instead of print line. So you just system.out.print, and it leaves you at the end of the line. So critical to all of this is the idea of a class. So class, I'm just going to call it my class. So when you define a class, we can do like we did in C. We can define a class and we can put some fields in there. And then if I want to make a variable of this type, I could just say something like my class CL. And now CL is a variable of type my class. Okay, so we want to change our terminology a little bit because I'm using some terms that aren't actually object oriented. So my class is a class. CL is an object of type my class. We can think of CL as just being a variable of type my class, but we're going to use the term object for variables like this. And we'll see why in a little bit. So when we do this declaration, we're saying that CL is an object of type my class. Now we're not going to do malloc statements in Java. We're not going to do the free statement. We're not going to use pointers. Okay, all that stuff is behind us now. It's all handled inside the Java virtual machine. So we can do something like this, but I want you to think for a moment, and we'll get away from this eventually, but think for a moment of how we did this in C. We'd say something like struct my class star CL. That's sort of what's happening here when we say my class CL. So this is in C. And this is in Java. And you remember in C that if we declare this thing to be a pointer to a struct my class, we can't start using CL right away. If we do, we get a seg fault, right? All we've done is we've told the compiler CL is going to refer to a my class, but it doesn't actually refer to anything in particular yet. It's uninitialized. And so in C, we would say something like CL equals malloc, and we put in the size of a struct my class. And now C1 is actually a genuine bona fide variable of this type my class. It's actually pointing to something in memory. We need to do something like this in Java also, okay, but it's not a malloc statement. It's much more friendly sounding. So we can say CL equals new my class with parentheses. And this is what we call constructing or instantiating this object C1. So when we do this, we can say CL is now an instance of my class. Okay, so how can we think of this? My class, this class is like a blueprint. It's saying if you want a my class, you're going to have an integer named X, you're going to have a character named C. And here you're saying, okay, I want CL to be one of these my class things. Okay, so you're saying I want you to use the blueprint for a my class when you make me a CL, but you haven't made a CL yet. This is what actually creates this object CL. So it creates an instance of this blueprint, this class called my class, and now CL is a genuine object. And at that point we can say something like CL.x equals, right? We can start referring to the fields of CL.
So we're going back to dot notation.
So we're going back to dot notation. There's no arrow notation because in some sense everything is always going to be pointing to a structure, but we're not going to deal with that ourselves. Right? When we say my class CL, it's understood it's going to refer to an object of type my class. So we pull off a field by saying CL.x or CL.c equals quote whatever. So up to this point, classes and objects can feel sort of like structures and pointers to structures that we were doing in C. And we're still not very object-oriented in that mindset. Get rid of that, 'cause we're not going to do mallocs. Okay, so here's a class called my class, and it's got 3 integers, x, y, and z. Well, here's the simplest class. Okay, that's the class declaration. It's not defining anything. I'm just saying I have a class called my class, and there's really nothing going on in there. So let me make a main program. Okay, so there's a main and there's a my class. So I'm going to compile main.java. And when I do that, I get a main.class, but it also created a myClass.class for me, because it knows inside main that I'm trying to deal with this thing called a myClass, and it didn't find a myClass.class, but it found a myClass.java, so it compiles that up for me. So now I've got two classes, main and myClass, and I can execute main, and it doesn't do anything. That's okay. We didn't tell it to do anything other than create, define CL to be a myClass.
Does it give you an error if myClass doesn't exist?
Yes. So if you use myClassy, it'll complain that it can't find that symbol.
It just has to be in the same folder.
Yeah, you can set up paths and do all kinds of fancy things, but in general, if it's all in the same directory, you should be fine. Okay, so we're going to do something different in myClass. We're going to define a variable called x, and we're going to set it equal to 10 in the initialization. So now this is a very fancy object. It has one piece to it. And we can compile it, and we can run it, and it still doesn't do anything obvious. So let's do something in our main program. Let's print out the value of cl.x and see what happens. So I'll use our print line statement, cl.x equals, and we'll tack on the value of cl.x. And it's not even going to compile it to me. It's warning me that CL might not have been initialized. CL might not actually have a meaningful value yet. Right now in C, we do this and it compiles and we run it and we get a seg fault. Why? Because CL is probably 0 and we try to dereference it and memory location 0 is protected. But it's warning us that there's a problem at this line right here, and sure enough, CL, we've said it's a variable of type myClass, but we haven't set it equal to anything. We haven't constructed CL. So CL equals new myClass. So let's construct the object. Comments are the same as C // or /*//. So now we're constructing an object of type myClass, and we'll print out the X field, and we should be all set. So, except if we're not. So there it tells us cl.x is equal to 10. Well, when we did linked lists, trees, hashes, all these other things, we always had to do some initialization, right? We would set up something to be a pointer to a struct node, and then we'd call a init, and it would set the data field to 42 and the next field to null, and that was creating our sentinel node, right? Very common that when you create a data structure, you need to do something the first time that you create it before you actually start using it. And we already have something here that looks like a function call. When we construct our object, CL, we're saying set it equal to a new version of myClass, parentheses, right? Parentheses usually mean there's a function involved. What we can actually do is inside myClass, we can create a function called myClass, and it's called a constructor. So this is a constructor for the class. And everything that we do in between here will get executed anytime that we say new myClass. So let's just do something goofy. So we'll just put a print message in the middle of our constructor. You don't normally want to do this, right? It's like having Malik yell at you every time you do something. But we're just going to put a print statement in there to see when it's actually constructing this object. And sure enough, before it does that print of cl.x, it tells us I'm constructing a my class right now.
So would that my class basically be kind of like a main for that?
In some sense, it's sort of like a main for the class. It's the first thing that will get executed, right, when we construct a my class. It's the only thing that will get executed when we construct a my class. So it's sort of a little like a main. Here's something else we can do. So we've got this variable x in my class, right? It's a variable, we can say variable name dot x, and it was giving us 10. But now our constructor is going to actually take an argument. And we're saying it takes an integer argument. And whatever value we pass to that constructor, it's going to set x equal to that value. So in our main program, I can say something like CL equals new my class 42. And when I do that, this constructor will get a value of 42. It should set x equal to 42. And then when I try to print cl.x, I should see a 42. I wouldn't be here if this wouldn't work.
So does it completely invalidate the other initialization you're making within my class?
Yes, so that x equals 10 does nothing. Because anytime that I construct this, I'm going to give it a value and it's going to set x equal to 10. So here's something really trippy though. Here's another function named my class that doesn't take an argument. And this is another constructor. I have two constructors for this class. One that takes an argument and sets x equal to that argument, and another that doesn't take an argument, but let's go ahead and print something in here. So that's useful. So now if I construct without an argument, it shows me that it was running that second constructor by saying haha and x is equal to 10. And that should make perfect sense because in the class, if we construct without an argument, right, all it does is this one print statement, and so x still has this value of 10. But if we construct with an argument like 42, it's going to set x equal to that value.
And if you pass in something that doesn't match one of the arguments, does it complain or does it default to it?
Like that?
Yeah.
Good question. So again, it will keep you safe from yourself. It'll say, I'd kind of like to see an integer, and you're passing in the string hello. I don't know how to turn that into an integer. It's an error. It doesn't compile. Mm-hmm.
What happens if that second my class doesn't exist, but you don't give it a number?
So we are heavily in the realm of these are good things to play with. So I'll just rename it instead of deleting it. So there's no my class without an argument, and oh, that's not relevant. Oh, I'm getting into big trouble. Yeah.
Does that?
Yeah, if you put void there, wouldn't you make that appropriate for like one of those subclasses?
Yeah, you got to say public before void. That was my bad. So here it's saying constructor in my class, which is expecting an int, cannot be applied to the given value, required an int, right, and found no arguments. So it's not matching up.
Okay.
So this is kind of a new concept compared to C. This is something called a signature. So in C, we can make a function, and we can say it returns an integer, and it takes a character, a pointer to a struct node, and a string, or whatever. And we call this function haha, right? And we can call haha, and we might pass the wrong types of arguments to it, and the compiler doesn't care, right? It will generally just compile, and it'll run, and it will segfault or step on memory or do whatever it is that the binary code says to do. Because in C, the only thing that really identifies a function is its name. If we have a function named haha, and we call a function named haha, it assumes we're talking about this function. Okay? In Java, the identity of a function is much more complex. It's not only the name, but it's the types of arguments that it expects. So I can have a function that takes no arguments, and I can have a function that takes an integer. They have the same name. They're different functions. Okay, so this is called the signature of the function. We're going to get away from the term function pretty soon. But it's called a signature. And so it's perfectly legal, and it's encouraged to have functions with the same name, but different lists of arguments, different types, and that makes them different functions. Right. Now this has exactly the same signature as the previous function. Let me put the word public back in there. It doesn't really matter, but just to make them look the same. These two things have the same signature. Even though they have different variable names, the name is irrelevant. Right? It's a function called myClass. It takes one argument, which is an integer. That's its signature. Okay. Second function is exactly the same thing. It'll complain if I try to compile this. But if I do that, now I've got a new function, different signature.
So if you have two signatures and you call like CO is equal to new my class and you pass in 42, which one does that go to?
Oh, and the complain first, since they have basically the same signature.
If I had them both the same,
Yeah, if they both had an
it won't
integer-
compile.
Oh.
Yes.
So once they would different, like one took in one integer, the other took in two.
If you have two integers, then if you construct with two integers, it will use the one with two integers declared.
Okay.
So this one, it'll complain at the second constructor that the constructor's already been defined. But if you do something like this, right, that'll compile, but I complain because I'm trying to call something with no arguments, and I don't have such a thing. But if I do that, that'll be fine.
And that works for the first signature?
This would, since I'm constructing my class with two integers, it would use this constructor right here.
Okay.
Yeah.
And then if you do one, you just do which first one?
Do one integer, it'll do the first one. If I do any other set of arguments, it'll complain when I try to compile.
Okay, I see now.
Okay, cool.
What you put in there is referencing what type of signature you're working with.
Yeah.
Okay.
All right. So far, this is a different version of structures in C. Right? It's the same basic concepts other than signature, but we can define a structure with some fields, and we can access those fields with dot notation. But we can do something much more powerful. So in C, we have a structure. It says this is an integer, this is a string, this is an array of floats, and so on and so forth. And then we can say variable name dot field to pull off that field. What separates an object or a class from a structure is we don't just have to put data inside this class, we can also put in code. So we can do something like this. Right, this is all part of the definition of what a my class is. It's got an integer named x. It's got a constructor that takes an integer value. Let me get rid of this constructor just to keep things streamlined. It's got a constructor that lets me give it a value for x, but it's also got a function called double x. And double x is going to return an integer. And what double x does is it takes the value of x and multiplies by 2 and returns that. So how do we use this? We can say something like CL equals new class 12. We can print out the value of x. And we'll print out the value of CL dot double x. And it should just be twice the value of x. So now we have a genuine bona fide object at play. So the correct term for these functions is actually method. Method is just a fancy term for a function. So we would say that my class is an object, is a class that has an integer named x and it has a method named double x. Okay, why is this useful? So doubling x is not that sophisticated of an operation, but suppose it was. Suppose it was some novel concept and it was much more complex than just multiplying by 2. We wanted to do something very fancy like add up all the numbers from 1 to x and return that. We can take all of that behavior, the algorithm for that, all the code, and we can put it inside a method like this. In fact, let's just do that. So we'll just say triangle. All right, so we'll make a little loop here. We'll have a running sum initialized to 0. We'll go through all the integers from 1 up through x, and we'll add those to our running sum, and we'll return the running sum. All right, so 12th triangle number is 78. So what is this going to do? We've got two my classes, CL and C2. CL is a my class 12 and C2 is a my class 5. And I'm doing the same kind of thing here. I'm printing out CL.triangle, I'm printing out C2.triangle. But I'm going to get different results when I do that. Right? Because CL.x is 12, C2.x is 5. CL triangle is 78, C2 triangle is 15. So what's happening here? When I say C2.triangle, triangle is an object of type my class. So it looks inside this object for a definition of triangle. There it is. It doesn't take any arguments. I didn't say print triangle of 12 or print triangle of 5. I said print CL's triangle method. But inside here, I'm using this variable x, and x is one of the data fields in this class. And so when I constructed C2, I gave an argument of 5. That set this x equal to 5. That's the value that's being used when I say C2.triangle. It's iterating up to 5. When I say CL.triangle, it's iterating up to 12. So you can think of this as a whole little factory, right? It's got methods, things that do work. It's got variables, data that gets acted on. And it's kind of its own little thing, right? It's an object. It's its own little entity. And when I say CL.triangle, right, I'm running this code. What's the value of x? It's that value that's sitting there in this other part of the factory. And this is really the idea of object-oriented languages, is we take the data and we take the code and we bundle them together. And just by saying CL or C2 or student 1, we have this whole glom of data and code gathered together in this single variable, this single object. And it's kind of a fundamentally different mindset from languages like C, where we would say something like triangle parentheses CL.x, or triangle parentheses C2.x, right? The code, the method triangle is actually part of it, and we access it just by using this dot notation, just like we pick up C2.x. Does that make some sense? So if it feels natural, good. If it doesn't, it will. Right? The more you mess with it, and eventually, this is like the only way that you can imagine doing structures, right? I mean, for most people, it starts to feel very natural and very reasonable. So on the 223 website on Canvas, I have a link. It says Java documentation. And click through to that. This is Oracle's main front page for Java. And most of what we're going to look at are the core API docs, and we're probably all working with Java version 8. So you want to click on this one. And this brings you to a page of documentation. And it can be a little overwhelming to navigate this at first, but basically everything in Java is a class. Okay, integers are classes, strings are classes, linked lists are classes, but there's actually like dozens of kinds of linked lists, and all kinds of different versions of trees, and lots of different kinds of arrays, and all of these things are documented in here. This is sort of a front page to it all. So let's just come down here to string. So string is a class. Okay, we've said that we can say string arg, and that's a string. It's something that holds a bunch of characters. But we're actually declaring an object of type string. String is a class. And there's different ways to construct a string. So we can just say string paren. We can say string with an array of bytes. We can say bytes and offset and length and all kinds of things. We can also say, string str equals quote hello, and that'll set it equal to that set of characters. But strings also come with all these methods. So if we want to know what the fifth character of a string is, we don't say string bracket 5. We say string dot char at parentheses 5. We run a method. If we want to know how long a string is, we don't say string length parentheses str. We say str dot length. And so you might have 3 strings, S1, S2, and S3. If you want the length of one of those strings, it's that variable name dot length parentheses. Okay, in C you say string length parentheses S1 or string length parentheses S2. you have this sort of arbitrary function called string len, and you pass it a string, and it gives you back a number. But this string length function really only makes sense with strings, right? So we move it from this outside place to being a part of the string itself. And now every string comes equipped with the code necessary to figure out what its length is, or to figure out what the last occurrence of some substring str is, or to see if it matches some regular expression, or to concatenate it with another string, or to convert it to uppercase, or to compare it to some other string. And all of these methods, all this code, all this functionality is available inside any variable you declare to be a string. Okay, so this is code reuse, right? All this stuff, you get it for free when you say string s. Now you can say s dot any of these things. If you want to get rid of leading and trailing white space, you just say s dot trim, bang, white space is trimmed. So a lot of what you do in Java is getting to know the classes, right? And when you're working with a string and you say, I want to convert this to uppercase, do you go through character by character and add 32 to the ASCII code if it's between this and that? No. You come to your documentation and you search for uppercase or uppercase, and you say, oh, there's a to uppercase method. And you just say s dot to uppercase parentheses parentheses, and it'll return the uppercase version of your string. And this is what we're going to be doing throughout this course, right? It's basically going to be working with classes with all these mechanisms built in, but we're also going to be writing our own classes. And we're not going to write a function that we pass an object to. We're going to write methods inside classes, and they're going to be a part of that object. All right, so that's a good stopping point for today. That's we'll continue with this tomorrow, and we'll also take a look at the first programming assignment tomorrow.